So in our previous classes, we were studying about the geometric design of the tracks, and we have already discussed about what is the necessity to discuss, or what is the necessity to study the geometric design of the track. So we have looked upon some of the irregularities of the tracks. In order to overcome those irregularities, we have to design the track properly. To overcome those defects, we have to study geometric design. So under that, how we are going to study this geometric design is we are considering the several factors. We are going to consider several factors. Among those factors, we are going to select and study each and every factors. So in our previous classes, we have studied about the gradient and different types of gradients. So in today's lecture, we will look at the speed of the train. How the in our previous sessions we have looked upon how the gradient is going to affect the geometric design of a track. So in today's session we will look upon how the speed of the train is going to affect the geometric design of the track. The speed of the train depends upon the strength of the track and the power of locomotive. So what it means is if the track on which the train passes is strong enough to withstand the fast moving load of a train, then you can increase the speed of the train. So the use of diesel traction and electric traction, which can run the trains at higher speeds, also requires the strengthening of existing tracks. So if you want to move the train at higher speeds, you have to increase the strength of the tracks on which the train travels. Though the increased speed increases the capacity of the track and provides prompt services to the customers of the railways, but the high-speed trains, while I'm talking about high-speed trains, I'm talking about the speeds not of the speeds of 60 kilometers per hour, 70 kilometers per hour. And here the high-speed trains means the speeds which are more than about 120 kilometers, more than or equal to 120 kilometers per hour. The high-speed trains have to face the following dynamic effects in their operations. So when the train travels at high speeds, it has to face some of the dynamic effects. The various motions such as the pitching, rolling, bouncing, and lateral oscillations of the vehicles. So this is one of the dynamic effect. Next, moving on, the resonance between the frequency of application of load and elastic oscillation of the track structure as a whole or its components. The structure as a whole has to face the consequences as well as or the components of the track has to face the consequences or different dynamic effects. Next, the inertia or springing action of the track in, from and behind the wheels, effect of unbalanced weights, effect of unspringing masses, and suspension characteristics of the locomotive and carriages. So these are some of the dynamic effects which a track is going to face during the operation of high-speed trains. So for high-speed traffic, the track and the rolling stock have to be designed and maintained properly so as to limit these oscillations which cause wide variations in the vertical and lateral forces. So this is the explanation regarding the speed of the train. Next, moving on, we will look at the safe speed on the curve. What is the safe speed? If a train has to go past a curve, what is the safe speed it has to follow, or what is the safe speed it has to travel at? The safe speed for all practical purposes means a speed which is safe from the danger of the overturning and derailment. If the train is passing at certain speeds, it should not overturn the train or it should not derail the train with a certain margin of safety. This speed to negotiate curves safely depends upon the following factors. So the safe speed depends upon the following factors: the gauge of the track, the radius of the curve, and the distance at which the resultant of the weight of vehicle and its centrifugal forces act from the center of the track. So resultant and centrifugal forces, if you want to understand these concepts better, you have to go back to your engineering mechanics. So resultant of certain forces, we have looked upon the different resultant of different types of forces, right? So the distance at which the resultant of the weight of vehicle and its centrifugal force acts from the center of the track, the amount of super elevation provided, the presence or absence of the transition curves at the ends of the circular curves. These are some of the concepts we have to look upon in case while studying the safe speed of the train while going past a curve. So we will look upon certain formulas which have been given by Indian Railways. So which have been formulated by in India. The following formulas are given by Martin, were generally employed to work out empirical and the safe speed of the curves.